Hello children, welcome back to my channel. I have started doing 10th class maths syllabus. First chapter I am doing, that is real numbers. So in this real numbers, yesterday I have done up to finding out HCF by using Euclid's division lemma. Now we are going to do the next part. Before going to do that, let us see what is today's proverb. The proverb what I have taken today is what you sow, you reap. Means what children? It's a good lesson for all of us. The farmer, if he sows a mango seed, he cannot get an apple seed, apple fruit. Whatever he is sowing, he is going to get the same thing. The same thing applies to our life also, children. Whatever we do, we get it back. If you do good to the others, you will get good back to us. Definitely, we will get good back. If you do bad, it comes on one day or the other to us. Just like you hit a ball to the wall, it comes back to us. Sometimes even with more force than with what you are hitting. So, criticizing others, teasing others is not a good job, children. So, develop a habit of always be good with others so that you always receive good only from the others. Now, let us come back to our topic. I have done Euclid's division lemma in previous topic. Now, I am going to do with the examples that are given in your textbook. The first one is example 1, and this example 1 is given in your page 5. What is that example 1, children? Example 1. It is show that it goes like this. See children, I'll read this for you and I'll do because the lengthy problems is not possible to write. Show that every positive even integer is in the form of 2q and every positive odd integer is of the form of 2q plus 1. Even is 2q, odd is 2q plus 1, where q is some integer. This is the problem given to you. So, in order to do that, what you have to take, an integer. So, let us suppose that let a be a positive integer. Okay, now what is Euclid's rule? What does Euclid's rule says? A is equal to bq plus r, where 0 less than equal to or less than b. Now, according to problem, in the problem, what they have given to you children? A is equal to 2q or A is equal to 2q plus 1. This is given to you. That means what children see? Euclid division rule is A is equal to bq plus r. So here you have got A is equal to 2q or A is equal to 2q plus 1. So in this case, in the place of B, you are having 2. In the place of B2 means, what will be the R? R will be either equal to 0 or less than B. So it will be 0 and 1 only. R is equal to B is 2, R is equal to 0 and 1. So if you consider R is equal to 0, then A is equal to 2q plus R, no? R is what children? R instead of R, I am taking it as 0. A is equal to 2q plus 0. That means A is equal to 2q. What is 2q children? Even. A is even. Okay. Now, if you take r is equal to 1, then a is equal to 2q plus 1. See children, when we have considered 2q as even, 2q plus 1 is odd, no? Therefore, a is an odd integer. So this is what they have asked you to prove. What is that they said? Show that every positive integer. So we will say that every positive even integer is 2q and every positive odd integer is 2q plus 1. This is how we have proved, children. So go through it. I hope you have understood, children. According to the values that they have given in the problem, you should take b value. Basing on the b value, you have to take r, and substituting the r, if you proceed with the problem, you will get what they have asked. They are asking to prove that every positive even integer is in the form of 2q. So 2q means in this case what you are getting, a is equal to 2, b value is 2. When b value is 2, r value should be what according to this? 0 less than equal to r less than b. That means r value should be either 0 or greater than 0. But r value should be less than b. Here we have got b as 2. So r value will be either 0 or r value will be 1. The next number will be equal to 2. So that is why we are going to take it that. So if r is equal to 1, what you will write, children? A is equal to 2q plus 0. That means 2q. Multiple of 2. Any multiple of 2 is even. So it is even. Next, if r is equal to 1, then a is equal to 2q plus 1 you will be getting. So even plus 1 is odd. So we have proved this. I hope you have understood. You copy this, children. Now we will be going to the example 2. What does the example 2 says? Example 2 in the same page. Every positive odd integer. So let me read this. Second one, they said, show that every positive odd integer is in the form of 4q plus 1 or 4q plus 3, where q is some integer. Odd numbers are 4q plus 1 and 4q plus 3. You have to do. You have to find out. So let me see this. What is a? Let a be a positive integer. Now, in this case, if a is a positive integer, what is Euclid's rule? Euclid's rule says that a is equal to bq plus r, where 0 less than equal to r less than b. Now, according to problem, what did they say, children? A is equal to, what is the value that they have given? 4q plus 1 or a is equal to 4q plus 3. Now, in the place of b, you have got 4. So, we will be considering b as 4. If b as 4, what does this implies? R is equal to 0, 1, 2, 3. We cannot go further because it should be less than 4, less than b. So, let us consider. If r is equal to 0, then a is equal to 4q plus 0. A is equal to 4q plus 0 means A is equal to 4q. 4q can be written as 2 into 2q, children. 2 into q, 2q means what? 2 into multiple of 2. So multiple of 2 means A is even. We got A value as even here. Now, if R is equal to 1, then A is equal to 4q plus 1. When you said that 4q is even, then definitely A is odd. Now, when you take R is equal to 2, then A is equal to 4q plus 2. In this case, children, you can take 2 as common. 2 into 2q plus 1 you will be getting. 2 into 2q plus 1 means what? It is a multiple of 2. So, A is even. Okay, children, you are getting A as even. Now, if R is equal to 3, then A is equal to 4q plus 3. You cannot take 2 as common in this case. So, A is odd. So, in this case, the problem is asking you to prove that every positive odd integer is in the form of 4q plus 1 and 4q plus 3. Say, children, where I have written odd? I have written odd here. I have written odd here. Where? 4q plus 1, 4q plus 3. In the remaining cases, I have got A as even. Why? Because I could write them as multiple of 2. So, we will write that. Therefore, every odd positive integer is in the form of 4q plus 1. 4q plus 1 or the next one is 4q plus 3. This is how you are proving it, children. Find out. See this. I hope you have understood. Copy this, children. Now, with this, I have completed the 2 examples that are given in your textbook. Basing on these examples only, you are going to get certain problems in the exercise. We will be doing that also one by one. Now, we are going to go for exercise 1.1. Exercise 1.1. So, this exercise 1.1 is in your textbook, page 6, children. In page 6, you have got exercise 1.1. So, what is the first one? You have to use Euclid's algorithm. That is Euclid's division rule to find the HCF. You have to find out HCF by using Euclid's algorithm. The first problem given to you is 900 and 270. So I have explained you, children, earlier. The bigger value should be taken as A and the smaller value should be taken as B. So take 900 and divide it by 270. So when you take this 270, so actually 9, usually when you are going for divisions, you will see this first and first. You will read this table, no, 2 4s are 8. So in case if you take 4, 270 into 4, 0. 7 4s are 28. 4 2s are 8, 9, 10. This is bigger one. So 4 you cannot get. So what you have to go for, children? You have to go for 3. 3 zeros are 3 sevens are 21, 3 twos are 6 to 8. How much you are getting, children? 9. So, how will you write here? 900 is equal to 270 into 3 plus 90. This is the rough column. So you are getting it here. So now you take A as 270 and B as 90. So you take 270 divided by 90. 93s are 270, remainder is 0. So you will be getting that 270 is equal to 90 into 3 plus 0. So you got 0 for 90. So HCF is equal to 90 is the answer. So I hope you have understood, children. Already I have explained this in your examples in the previous video. Now let us see what is the second problem. The second problem is 196 and 38,220. So A we are taking as 38220 and B we are taking it as 196. So 38220 divided by 196. So 196 here 3 is there. So let us see, children. 196 into 2 if you do. 2 6 are 12, 2 9 are 18, 1 19, 2 1 are 2 and 3. It is 392 but we need 382. So even 2 is bigger one. So we will take 1. How much? 196. So how much you are getting, children? 6 here and 7 means 8 and 1. 186 you have got, carry, you take out 2 here, 1862. So you have to continue the division because we have not concluded this. So 18 means with which one see 6 suppose see in units place with this is hundreds place, no. So here if you cannot do, go for this 6 7s are 42. So in units place 2 we will be getting. So try for it, children. 196 into 7, 7 6 are 42, 7 9 are 63, 63 plus 4 67, 7 1 are 7, it is 1372. So 1372 is very small to this. So we go for 8th one. 196 into 8. 6 8s are 48. 8 9s are 72 for 76. 8 1s are 8. 7 means 15. Even this is less than 1862. So let us go for the next value. That is 196 into 9. 9 6 are 54. 9 1s are 9. 9 9s are 81 plus 5 86. 9 1s are 9 plus 8 17. So you will be getting 1764 which is nearer to it. So go for 9 1764. So what is on subtracting, children? 12 means you will be getting 8 here and here you will be getting 9. Because 5 you have taken, 15 means 15 minus 6 is 9. Now take out that 0. So you have 0 means 196 into 5 you see, children. 5 6 are 30. 5 9 are 45 3 48. 5 1 are 5 4 9. You are getting 98. So 5s are 9 80. So you are getting 0. So you have got 0. So what you are saying, children? 38220 is equal to 196 into 195. I'll do it down, children. Here place is less, so I'll be doing it here. 38220 is equal to 196 into 195 plus 0. So you got 0 for 196. So HCF is equal to 196. This is the answer for this problem. So I hope you have followed, children. Copy it. Now we will be seeing the third bit. What is the third bit given in this? The third bit is 1651 and 2032. It's the 1651 and 2032. So your A is equal to 2032, B is equal to 1651. So take 2032 and divide it by 1651. So suppose you take with 2, 1651 into 2, 2 ones are 2 5s are 10, 2 6 are 12, 1 13, 2 ones are 2, 1 3. It won't go. So we'll take 1. 1 6 5 1. How much you are getting, children? 1 here and here borrowing. You'll be getting 13 minus 5 8. 9 minus 6 is 3. 381 we will be getting. Therefore, what we will say? 2032 is equal to 1651 into 1 plus 381. Now, you take A as 1651, B as 381. So 1651 into 381. So here 1651 into 381 means 16 is there. 3. So 381 into 5. Let us see. 381 5 ones are 5. 5 eights are 40. 15 for 19. So it is bigger one. So we need to go for 4. When you go for 4, 4 ones are 4, 4 eights are 32, 4 threes are 12, 3, 15. You are getting 1524. So when you subtract, here you will be getting 7, here you will be getting 2, and here you will be getting 3. You are getting, already you have taken 1651. This is here 4 minus 2. Okay, 6 minus 5 is 1, no children. 127 you are getting. So 1651 is equal to 381 into 4 plus 127. So again A is equal to 381, B is equal to 127. So what you have to do, children? You take 381 and divide it by 127. So let us see 127 multiplied by 3. 3 sevens are 21. 3 twos are 6, 2, 8. 3 ones are 3. So with 3 you are getting 381 and 0. So you will be rating that 381 is equal to 127 plus 127 into 3. 127 into 3 plus 0. So we got 0 with 127. So HCF is equal to 127. This is your answer. So please copy this, children. This is the last bit of the first problem. Now we will see the next part. Second one. The second problem is just like the example sums which I have taught you earlier. So the second problem is use division algorithm, and it goes on like this. So what is this problem, children? Use division algorithm to show that any positive odd integer is of the form of 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5, where q is some integer. This is the problem, children. So let us suppose that let a be a positive integer. What is this Euclid's rule? Euclid's rule says that a is equal to b cube plus r, where 0 less than equal to r less than b. Now what does the problem says? According to problem, what did they say? A should be equal to 6 cube plus 1, or it is equal to or 6 cube plus 3 or 6 cube plus 5. Now in this problem, what did you get, children? The value of b. b is equal to 6 because you have got 6. What does this implies? R is equal to 0, 1, 2, 3, 4, 5. Up to 5 you have to take. Sixth one you are not supposed to take because R value is less than B. So let us take one by one. If R is equal to 0, then A is equal to 6q plus 0. That means A is equal to 6q. 6q can be written as 2 into 3q. 2 into some number is even. So you are going to get A is even. Now, if R is equal to 1, then A is equal to 6q plus 1. Definitely A is odd. When we have said that 6q is even, 6q plus 1 is odd. Next, if R is equal to 2, then A will be equal to 6q plus 2. So in this case you can take 2 as a common. 3q plus 1 you will be getting. Multiple of 2 is nothing but A is even. Now, when you go for R is equal to 3, then what is A, children? A is equal to 6q plus 3. You cannot write it as multiple of 2. You can write it as multiple of 3 but not 2. Therefore, A is odd. Now, if you take R is equal to 4, then what is A? A is equal to 6q plus 4. So in this case, you can take 2 as common, 2 into 3q plus 2. So A is even. Now you have got the last one, R is equal to 5. If R is equal to 5, then A is equal to 6q plus 5. That means A is odd. So, in which cases you are getting odd, children? 6q plus 1 you are getting odd. 6q plus 3 you are getting odd. 6q plus 5 you are getting odd. The problem itself is asking you that every positive odd integer is in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. So the same thing you have got it here. So that itself we can write. Therefore, every positive odd integer is in the form of what are they, children? You have got 6q plus 1 or 6q plus 3 or 6q plus 5. So this is what is your proof for this problem, children. So I hope you have understood. In every case, if you get this kind of problems, only the thing is you need to see what is B. Basing on the value of B, you have to go for R. Accordingly, you have to do the sum. Definitely, you will get the correct answer. I hope you have understood, children. So the remaining part, I am going to do it in the next class. Bye, children.